you all know, the definition of probability is, of course, like whatever is the desired outcome upon the total number of outcome. So when you look at the total number of outcome, that is also referred as sample space. So lots of times you'll come across the key terms that basically means that you need to understand, okay, that because of like, those key terminologies, you may lose certain number of marks. So sample space is basically the total number of outcomes that are possible. So first key term is your sample space. So sample space, let me give an example of that. So sample space, like if you talk about, if you're rolling a dice, unbiased dice, it can be these possible outcomes. So obviously this is your sample space. Similarly, like if you're tossing a coin, head or tail is sample space. So generally when you're looking at this as a probability as a key concept, so probability is basically if you're let's say an event which has got, let's say there are 6 outcomes, and out of that 2 of these are desired, so the probability is going to be desired out upon the total outcome. So that's your 2 out of 6 is the probability. As you know, this is a fraction with the smaller number in the numerator and bigger number in denominator. It will be practically impossible that probability exceeds 1. So any probability will be always between 0 and 1, and 1 being obviously 100% sure, 0 being the least. So when you're now, let's say if I go on to the types of events. Now before that, if we can understand a little bit about the set notation. So if you see this basic set notation, lots of times the students are confused about this, like, okay, which part is what? So if I say, okay, so this is set A, this is set A, and let's say this is set B. Now A can be any sports, B can be other sports. So let's say there are 7 kids here, 3 kids here, 5 kids here, and 2 are in neither. Now if I just ask randomly that, okay, what's the probability that if I pick up a person is from set A? So obviously we got, in total we got 7 plus 3 10, 10 plus 3 15, 10 plus 5 15, and 15 plus 2 17. So in total I have got a sample space of nothing but 17 people. Now if I'm picking up a person from set A, that chance is going to be 10 upon 17. If I'm picking a person from, let's say, set B, that chance is going to be 8 out of 17. From random set, like random set means you're picking up from the entire set of the people. Now there are certain key terminologies, let's say these are something that we need to understand. So if they ask you A complement, let's say number or probability, I would go ahead with the probability. Probability of A complement, probability of A intersection B, probability of A intersection B complement, probability of A complement intersection B complement. To a lot of extent, the students are not clear about these themselves. I mean, some of these are okay, these I know how to do it, but the other ones are like, trouble causing parts. So first thing is that what's A complement? When you look at A complement, it's basically everything outside A. So A complement will be probability of 1 minus A. So 1 minus probability of A is going to be the A complement. So what's outside is basically these are 7 that are outside. So that's nothing but either you can write down 7 out of 17, or you could do 1 minus probability of A. So 1 minus probability of A, when you're going to do that, automatically gives you 7 on 17. Of course, we all might be aware that, okay, what's intersection? So intersection is basically this part. So obviously the common part between both of them is referred as intersection. So when you're talking about probability of A intersection, it's going to be 3 out of 17, provided there is no condition applied that, okay, I'm picking up from A or B. Okay, so it's picked up from random sample of 17 people in the study. Now these two are like one of the important ones that are assessed across. So A intersection B complement, when you talk about, now if you talk about A intersection B complement, so what's not part of B, or you can say what's outside B and is common with A? So that's nothing but 7. So these 7 people or 7 students are not in B, but they are in A. I mean, that's common in A. So that goes as 7 upon 17 once again. Now when you talk about A complement intersection B complement, so what's outside A as well as outside B? So intersection always means and. So whenever you're talking about intersection, it always means and. So outside A and outside B. So outside A is basically and outside B is also 2. So that's gonna be 2 out of 17. So this is just about the general set rule, like this is for 2 Venn diagrams. There can be 3 Venn diagrams also, which kind of the procedure is pretty similar. Remember that whenever you talk about intersection, that's common. Whenever you talk about union, that's like combining 2 sets. So let me just now go to we'll touch base upon more of the questions as we progress, but let me go on to the types of events. So when you talk about types of events, so let's say there are 2 types of events you have to study: exclusive and independent. So what's the difference between these 2 events? Firstly, to the ground level, and also how do we differentiate between these 2? Now lots of times we're confused about, okay, we take exclusive as independent and independent exclusive. Now before I go ahead, I would just like to write down the formula that we have. The formula that we have is basically, let's say if you got 2 sets A and B, the probability of A union B is probability of A plus probability of B minus probability of A intersection B. So A union B is probability of A plus probability of B minus probability of A intersection B, because if you look at, when I add a probability of A, this entire set comes, then probability of B, this entire set comes. So if you see the intersection is overlapping twice, that's why we subtract it once. So this is the general formula for any two intersecting sets, and this is used extensively for HLSL both. Now coming to what exactly do we mean by exclusive events? What is exclusive? Now if I can give you a simple example, let's say a mathematics group, or let's say group 5 of IBDP, we are picking up, let's say, math HL and SL. A student wants to pick up math HL and SL to study, which is impossible. So a student can't exclusively take both the curriculums or both the courses in for study. So basically, if 2 sets that are disjoint, like they are referred as an exclusive set. So if 2 sets are disjoint, like what I've shown here, basically will be referred as an exclusive set. So here, if there is no overlap, means if the 2 courses cannot be taken together, then it's exclusive. So how do we categorize that an event is exclusive or not? Simply remember that if your probability of A intersection B is 0, we call the events are exclusive. So if events have to be exclusive, this is the must condition. And lots of times they ask a critical thinking based question, that why the events are not exclusive. So if they're not exclusive, it means that there must be some overlap. So that's an example of exclusive and I can give. And now coming to independent. So just before I go to independent, if you see the formula that modifies for A union B is probability of A. So probability of A plus probability of B, because this part, if you see, probability of A plus probability of B, because this part is already 0. So if this part becomes 0, this part becomes 0. So simply what we get is, we get PA plus PB. So this is also, if we refer, this is like OR condition. OR is addition and is of course the multiplication. Now I'm coming to that part also. So now coming to the independent. Now see, in independent events, these 2 events can occur together. So there can be an overlap of the two set notations. So let's say if you have got a team of, let's say, football players and a team of basketball players. So let's say there are 3, 5, 2 and 7. Now suppose that there are certain players who have taken both the sports, football and basketball. Now when I talk about independent event, as the word itself suggests, that independent is that one event should not affect the probability of the other event to occur. So if I'm asking, okay, let's say there is a football session, and if a person is giving a excuse that, oh, I've got a basketball, then they are not independent. So logically, here there is a condition that we got to remember, okay? So probability of A intersection B, if it is equals to probability of A times probability of B. So this is AND condition. If you see, intersection is AND. So if A and B, we are finding if it is equals to PA into PB, then we call the events to be independent events. Now, if you look at for this set, how do I check if the events are independent or not? So this can be 5 out of, let's say we got 3 plus 5, 8, 8 plus 2, 10, and 10 plus 7, 17. So 5 out of 17 is this answer. Now, probability of A is going to be 8 out of 17 times probability of B is 7 out of 17. So, as you can see that if I cancel out these two things, the probabilities are not coming to the same value. So simply indicating that these two are not independent. So here, if one event is affecting the probability of other, it will be called not independent. So this is about like your exclusive and independent events. This is the general idea about how do we call, when do we call an event to be exclusive or when event is independent. So let me just give you the final formula for this. So the final formula that we have got is, if you have got probability of A union B, probability of A union B is PA plus PB minus PA times PB. So this is the formula for the for the independent event. So if union of the two events that are independent, I can use this formula to calculate the probability of what's probability that a student takes A or B sport. So this is more or less about the condition or different kinds of events. So let me just give an example now. Now consider that there are two set. So probability of A is, let's say, 0.3. Probability of, let's say, B is 0.2. It is given that these two events are independent. Given that these two events are independent, find out the probability of A union B. So given that these two events are independent, you have to find out the probability of A union B. So obviously, if you simply see, that's probability of A plus probability of B minus, instead of intersection, since the events are independent, probability of A intersection B is going to become probability of A times probability of B. So that's your independent event condition. So this will be PA times PB. One of the favorite question of this kind is generally assessed in like HL or SL course. So this is going to be 0.3 plus 0.2 minus 0.3 into 0.2. So straight away you can see this is the answer. If these two events are independent, this is the probability of A or B basically. So one of the kind of question that has been assessed also in IB is where they give an equation solving, like problem based on equation solving skill. So let's say they give us that two events are independent and it has been given that probability of A is 2 times probability of B. It is given that probability of A is 2 times probability of B, and what we are supposed to find out is, it is also given that probability of A union B is 0.8, and what you have to find out is what are the individual probabilities. So when you're finding out the individual probabilities, so here what's going to be is, let's say probability of A union B is going to be, let's say I take this as, let probability of B be X. So probability of A union B, first you write on the formula. So if you write on the formula, That's probability of A plus probability of B minus probability of A into probability of B. So first, once you've written the formula, then we can substitute their value. So this value we already know is 0.8. After this we got are the right hand side values, which are like probability of A is 2 times x plus probability of B is x minus 2x times x. So you can see that it's a quadratic equation. If you solve it, it becomes 2x squared plus 3x and minus 3x if you solve it, because you move it to the other side, and plus 0.8 equals to 0. So if you solve this, you're going to get the probability of B and hence the probability of A.